Hello guys, welcome back to my YouTube channel. In today's video, we are going to discuss the topic of class plus 1 physics, that is motion in a straight line, which is also called rectilinear motion. As we know, there are many types of motion, like motion along a straight line, which is also called rectilinear motion, circular motion, rotational motion, periodic motion, and oscillatory motion. Out of all these type of motion, we shall confine ourselves to the motion of an object along a straight line, which is also called rectilinear motion. So in this video, we will discuss only the rectilinear motion. In this video, we are going to discuss the topics motion, frame of reference, path length, displacement, and position time graph. So let us move to our first topic, that is motion. So when an object is said to be in motion, an object is said to be in motion if it changes its position with time. Let us discuss it in detail. Consider we have a car which is at point A at some point of time, let us say at 10 a.m. At some another point of time, let us say at 10:05 a.m. It is found to be at point B because car had changed its position from A to B in 5 minutes. So we can say that car is in motion. Let us move to next topic, that is frame of reference. Frame of reference. As we have learnt that to study motion, we deal with change in position with time. So to describe motion, we need to describe position of an object, and to describe position, we need a reference point, which is called origin, set of reference line, which is also called set of axis, and to measure time, we need time clock. So frame of reference consists of these three components: origin, set of axis, and time clock. Question arises in our mind, why we need frame of reference, means why we need origin, why we need set of axis. Let us discuss it in detail. For this, let us consider a situation. Let us say this is your town, these are streets in your town, this is your house, this is your friend Anil's house, this is your friend Mohan's house, this is Sohan's house, this is Rakesh's house, and this is a park in your town. Now you want to invite your friend Anil to your house. Then how you describe position of your house to Anil? You will say that my house is 120 meter right to your house. Now in the second case, if you want to invite your friend Mohan to your house, then how you describe position of your house to Mohan? You will say that my house is 200 meter left to your house. From here you can see that position of your house depends upon the point of reference from where you are measuring the distance. If you are measuring the distance from Anil's house, it is 120 meter right, and when you are measuring the distance from Mohan's house, it is 200 meter left. So to describe the position of your house completely, you need to describe the point of reference from where you are measuring the distance. It is not sufficient to say only that my house is 120 meter right or 200 meter left. You need to say that my house is 120 meter right from Anil's house or 200 meter left from Mohan's house. So to describe the position of your house completely, you need to describe the point of reference from where we are measuring the distance. Now, if you want to describe the position of your house in a single way to both of your friends, then you need to choose that point as reference point about which both of your friend know. Let us say this left corner of the street is such point about which both of your friend know. Then you will describe the position of your house by taking this left corner of the street as reference point, and you will say that my house is 300 meter right from the left corner of the street. So by choosing this left corner as the point of reference or origin, you can describe the position of your house in a single way to every person who is living in this street and who know about this reference point, and this reference point is also called origin. So you can describe the position of your house as it is 300 meter right from left corner of the street to every person who is living in this street and who know about this reference point. Now you want to invite your friend Rakesh to your house who is not living in your street. Then how you describe position of your house to Rakesh? Because here motion involved is in two direction, so you need to choose two reference lines, one vertical and other is horizontal, which are passing from Rakesh's house. So you will choose this horizontal line as horizontal reference line which is passing from Rakesh's house, and this vertical line as vertical reference line which is passing from Rakesh's house. And point of intersection of these two reference lines is called point of reference or origin. So by choosing this horizontal line as horizontal reference line and this vertical line as vertical reference line, you will describe position of your house as it is 100 meters south and 200 meter right from Rakesh's house. So position of your house is in right or left, it will depend on the vertical reference line, and position of your house is in south or north, it will depend on the horizontal reference line. Now when you are describing position of your house by taking Sohan's house as reference point and two mutually perpendicular lines which are passing from Sohan's house as reference lines, one is in vertical direction and other in horizontal direction, then you will say that my house is 100 meter north and 198 meter left from Sohan's house. Here in this case, we have chosen this vertical line as vertical reference line and this horizontal line as horizontal reference line. Now, if you want to describe position of your house by taking park as reference point, then you will choose this horizontal line as horizontal reference line which is passing from park and this vertical line which is passing from park as vertical reference line. And then you will describe position of your house by taking park as reference point as it is 200 meter north and 100 plus 120, 220 meter right from park. Now, if you want that you describe position of your house in a single way to every person in the town, then you will choose a reference point or two reference line in such a way that everyone know about the reference point and reference line. If you choose this corner point as reference point and this left edge of the town as vertical reference line and this bottom edge of the town as horizontal reference line, then you will describe position of your house as it is 150 plus 200, 350 meter north and this 100 plus 80 plus 120, 300 meter right. So position of your house is 350 meter north and 300 meter right from this left corner of the town. So this was all about the need of point of reference which is called origin and need of reference lines which are called axes. Let's move to the next topic, that is path length. So what is path length? Path length is total distance moved by the object during the course of motion. To understand this, consider the motion of a car along a straight line. Consider this is a car which is moving along a straight line. For motion along a straight line, we need to choose a reference line which coincide with the path of motion of car. This line is called x-axis. Let us consider this is origin which is starting point of car and all the distances will be measured from this point P, Q and R are the positions of car at different instant of time during the course of motion. Distance between O and P is 150 meter. The distance between O and Q is 400 meter, and the distance between O and R is 100 meter. Consider in first case the car moves from O to P. In this case, the distance moved by the car is the distance OP, which is 150 meter. So in this case, the path length will be the distance OP, which is 150 meter. In case 1, car moves from O to P. So path length in this case is distance OP which is equal to 150 meter. Consider the second case. In second case, car moves from O to Q and then back from Q to P. During this course of motion, the distance moved by the car is OQ and QP. So the total distance moved by the car is OQ plus QP. So path length here will be OQ plus QP. In second case, car moves from O to Q and then back from Q to P. So path length in this case will be total distance moved by the car, which is OQ plus QP. OQ is 400 meter and QP is 400 minus this 150, which is equal to this PQ distance will be equal to 400 minus 150, which come out to be 250 meter. So it will be 250 meter. So total path length will be 650 meter in second case. In the third case, consider the car moves from O to R. In the third case, car moves from O to R. So the path length here will be the distance OR, which is equal to 100 meter. So this was all about the path length. Let's move to the next topic, that is displacement. So what is displacement? Displacement is defined as change in position. Consider x1 and x2 be the positions of an object at time t1 and t2. And the displacement of that object in time t2 minus t1 is given by displacement of that object in time t2 minus t1 is given by delta x, which is given by x2 minus x1. This delta x is displacement, which is a vector quantity. It is a vector quantity which has magnitude and direction both. Any quantity which has magnitude and direction both is known as vector quantity. In case of rectilinear motion, as we have considered in this unit, in case of rectilinear motion, direction is given by plus or minus sign. Rectilinear motion means motion along a straight line, positive or negative sign. Because here in this unit we are considering only rectilinear motion, so direction is given by positive or negative sign. To understand this concept clearly, let us consider an example of a car which is moving along a straight line. Consider this is a car which is moving along a straight line, and this is a reference line which coincides with the path of motion of car, and let us take this is origin, which is starting point of car, and P, Q and R are the positions of car at different instant of time during the course of motion, and the distance between O and P is 150 meter, and the distance between O and Q is 400 meter, and the distance between O and R is 120 meter. So in first case, when car moves from O to P, initial position of car is at origin, which is at 0 distance from the origin, and final position of car is at P, which is at 150 meter distance from the origin, and because it is on right side and all the distances on the right side will be taken as positive, so P is at plus 150 meter distance from the origin. So in this case, the initial position is at 0 distance from the origin and final position is at plus 150 meter distance from the origin. So displacement in this case is plus 150 meter minus 0, x2 minus x1. So it will come out to be 150 meter. So displacement in first case is plus 150 meter. Now consider the second case in which car moves from O to Q and then back from Q to P. In second case, when car moves from O to Q and then back from Q to P. Here in this case, the initial position of car is at origin, which is at 0 distance from the origin, and final position is again at P, which is at plus 150 meter distance from the origin. So here in this case, x1 is 0 meter and x2 is plus 150 meter distance from the origin, and the displacement here in this case x2 minus x1, final position minus initial position, which is given by plus 150 meter minus 0 meter. So it will come out to be plus 150 meter. Displacement in this case also is plus 150 meter. Although path length was in this case the distance OQ plus QP. It was 400 meter plus 250 meter. It was 650 meter. So we can see from here that displacement cannot be equal to the path length. Consider the third case in which car moves from O to R. In this case, initial position of car is at origin, which is at 0 distance from the origin, and final position is at R, which is on the left side, and all the distances in the left side will be taken as negative. So R is at minus 120 meter distance from the origin. So in this case, initial position x1 is at 0 meter from the origin, and x2 final position of the car is at minus 120 meter distance from the origin. So displacement in this case is x2 minus x1, which is minus 120 meter minus 0 meter, which is given as 120 meter. So displacement in this case is minus 120 meter. So from here we can see that displacement can be negative also. Displacement can be 0 also. To see this, let us consider one more case, which is case number 4. In this case, car moves from O to R and then back from R to O. In this case, initial position of car is at origin and final position is also at origin. So initial and final position are same. So displacement here is 0. In this case, initial position of car is at 0 meter from the origin because it is at origin, and final position is also at origin. So it is also at 0 meter from the origin. So displacement in this case is 0 minus 0, which comes out to be 0 meter. So we can see from here that displacement can be 0 also. So from here we have observed some interesting facts about displacement. Displacement may or may not be equal to path length. As we have seen, in first case displacement was equal to path length. In the second case displacement was not equal to path length. Also, displacement may be positive, negative or 0. As we have seen in first and second case, displacement was positive. In the third case, displacement was negative, and in the fourth case, displacement was 0. So it was all about the displacement. Let's move to the next topic, that is position time graph. So position time graph, what is the significance of position time graph? Motion of an object can be represented by position time graph as is shown here. On y-axis we represent position and on x-axis we represent time. Now for motion along a straight line, as we are considering in this unit, say along x-axis only x coordinate varies. So we take here xt graph. In place of position, we represent x coordinate on y-axis, which is in meter. So this is xt graph for stationary object. Stationary object means object is standing still, means it is not moving, and object is standing at x is equal to 40 meter. So from here we can see that x is 40 for all the time because object is not moving, it is standing at x is equal to 40. So the graph will be a straight line parallel to time axis. So for stationary object, the xt graph will be a straight line parallel to time axis. The second graph is for object in uniform motion. When an object is said to be in uniform motion, when object covers equal distance in equal interval of time. When object covers equal distance in equal interval of time means object moves with uniform speed or same speed during the whole course of motion. So xt graph for object in uniform motion will be a straight line passing through origin. Now the third graph is for object in non-uniform motion. Means object is not moving with the same speed, but it has different speed for different interval of time. Object starts from rest first and then picks up speed till t is equal to 10 seconds and then moves with uniform speed till t is equal to 18 seconds. From here we can see that it picks up speed till t is equal to 10 seconds. From t is equal to 10 seconds to t is equal to 18 seconds, it moves with uniform speed, then brakes are applied and it stops after 20 seconds. So this is the graph for object in non-uniform motion. So this was all about position time graph. Next topic we will discuss in the next video. Thank you.